In April 2024, more than a typical year's worth of rain fell on the United Arab Emirates in a single day. The desert city of Dubai drowned. Almost instantly, the internet pointed a finger at a single culprit: the government's weather manipulation program. Cloud seeding is a heavily funded reality deployed by governments worldwide. China recently increased ground-based operations by 20% to protect its grain belt from persistent drought, utilizing specialized artillery and aircraft to manage precipitation. The technology is also getting increasingly precise. In the United States, Utah operates a massive network of remote-controlled ground generators, and meteorologists are now flying specialized drones directly into storm clouds to pinpoint exactly where to release their payloads. But when climate scientists and meteorologists reviewed the data surrounding the catastrophic flooding in Dubai, they reached a unanimous conclusion: cloud seeding did not cause the disaster. Weather modification is an incredibly difficult, highly constrained science. We do not possess a weather weapon capable of conjuring historic storms on demand. If cloud seeding lacks the power to trigger a flood, why are the world's most powerful nations spending millions to negotiate with the sky? The first rule of weather modification is that we cannot create clouds out of thin air. To even attempt a seeding operation, you need a pre-existing cloud already packed with moisture. In colder climates, operators rely on glaciogenic seeding, a term for ice-forming processes. They inject a chemical compound called silver iodide into supercooled clouds to act as a nucleus, a tiny seed for ice crystals to grow on. Silver iodide's structure closely mimics natural ice. Water vapor molecules are naturally drawn to it, freezing and interlocking. As more vapor latches on, this artificial scaffold rapidly builds mass. The tiny ice crystal grows into a heavy snowflake, and gravity pulls it to the ground. In warmer climates like the UAE, the process utilizes hygroscopic seeding, meaning water attracting. Aircraft fire flares packed with microscopic salt crystals directly into warm clouds to force small water droplets to clump together into heavy raindrops. These microscopic chemical interventions are part of a global, desperate scramble to secure fresh water. If you want to understand the extreme lengths humanity will go to survive a changing planet, hit the like button and subscribe to the channel. We have mastered the microscopic chemistry of making rain, but forcing a cloud to actually drop that rain relies entirely on massive weather conditions that remain completely out of our control. To get a return on their investment, operators have to wait for a highly specific set of atmospheric conditions to align perfectly. Temperature is the strictest barrier. Glaciogenic seeding only works when the top of the target cloud sits between -10 and -25 degrees Celsius. This diagram illustrates orogenic clouds, formed when moisture-rich air is forced upward over a mountain range. Meteorologists track the air's movement through the cloud. Operators have a frantic 20-minute window on the mountain's upwind side to grow artificial snowflakes before the moisture evaporates. When every variable aligns, the temperature, the wind speed, and the cloud moisture, a seeding operation yields about a 5 to 20% increase in natural precipitation. That data point is the definitive proof against the viral Dubai myth. Pushing a storm to drop 15% more rain over a localized mountain range is a mathematical impossibility for engineering a countrywide disaster. While the internet worries about weather weapons, actual scientists are focused on very different problems. Environmental studies show that silver iodide concentrations in seeded snowpack remain harmlessly low, often under 0.98 micrograms per liter, well below the threshold for drinking water. The primary concern comes from institutions like the U.S. Government Accountability Office, or GAO. They recently pointed out a severe lack of reliable, standardized data to prove these operations are actually working on a large scale. The scientific dilemma is maddeningly simple. If you seed a cloud and it snows, it is nearly impossible to measure exactly how much of that snow would have fallen naturally versus how much was engineered. States are spending fortunes just to figure out if their prior investments were effective. Utah is currently launching the Snowscape 2026 research program, deploying high-resolution mobile radar units to map atmospheric conditions and definitively track the impact of their seeding programs. The GAO also warned that while current chemical levels are safe, rapidly scaling up these programs across the globe without international oversight could introduce ecological consequences we haven't predicted yet. yet operations continue to expand. As droughts accelerate and historical reservoirs dry up, fresh water is rapidly becoming the most valuable resource on Earth. Cloud seeding remains a scientifically complex, highly limited plea to a changing atmosphere.